Sorry for that. So the first item is we need to understand what a normal distribution looks like. Now I know that a number of us have covered the concept of normal distribution. Whatever route you have followed this program, somehow you have come across a normal distribution. But it's not a difficult distribution. It's not a difficult pattern, no. Most of the values that we deal with in our lives every day are actually normally distributed. If you look at the sizes of the shoes that we wear, if you look at the weight of items that are produced in a factory, if you look at the returns on investment, how much return you're making on investment, if you collected these values, let's say you take 1,000 readings, you take 1,000 men and you record the size of the shoes that they wear. If you take 1,000 items that you are producing in your factory, if you look at returns every day over a period of 1,000 days, you calculate the return that you get. All these values, if you come, one, they're going to have there'll be an average value. There's going to be an average. For instance, you may find that the average size of all these men for the shoes, it may be size 8. That will be the average. So out of these 1,000 men that you have, not everybody will actually be at size 8. Some will be at what? Others will be at it. Others will be at it. Others will be at 4. Now some of you are starting to laugh there. That Mr. Piri, can you get people, men with shoes of size 4? I like that. Already then, you are already saying that there's going to be very few observations this side. Then this side we go 9, 10, 11, 12, 13. I know Mr. Nkunguru is laughing now. 14. And it's right that you're laughing because you're saying, surely there will be very few observations on this side out of the 1,000. Where will be the concentration? Where will be the concentration? Where will be the concentration? Where will most of the people be? The concentration will be around 8, plus minus 8. Maybe from 6 to 10, isn't it? Now, this pattern that you see here, this bell shape, is what we call a normal distribution. And most of the values, if you went and you did a survey, a research, whatever it is, when you collect them and you come and put them on the graph, they will face a bell shape. We call this a bell shape. In other words, the data is normally distributed. Now, as long as you prove that the data is normally distributed, all data that is normally distributed has got standard features. Standard features, and these standard features are what we need for us to estimate variations. The variation from the average is what we call the deviation. And we can standardize this deviation and we term it your standard deviation. So if data is normally distributed, there is a certain percentage of items that will be expected within a certain level of variation. There's a fixed percentage of items that you expect to fall within a certain level. And it's been standardized. for every data which is not. So as long as you're told that data is not distributed, you don't worry, just go ahead and use those standard variables. For instance, when data is normally distributed, (68% of your items, 34% being on each side of your average, will fall within one standard deviation. One standard deviation that side, and one standard deviation that side. So it is known that 34% of your reading will be one standard deviation and one standard deviation. Now your question is, Mr. Pili, how do you know that they're 34%? It's because there's a table which has been prepared for us. A table has been prepared for us, and the table is which tells us that, if you look at one standard deviation above and below the average, there's a fixed number of items. So where is this table? So from here now we need to go to the table. The table is the one that tells us how many items are falling within which portion. So at this point, let us look at the issue of the number of items or the proportion of these items. Which items is this 1,000 here? The proportion of these items that will fall within the region of one standard deviation up and below. So let us share the next item. So we're going to share your tables in the exam. Let us share our tables in the exam. Okay. So a table will be given to you. So there's nothing to worry about in the exam. And we'll tell you which ones always come in your exam. Even the questions are fairly standard also. The questions are fairly standard. There are only 2 levels that we are looking for. So let us go for these these items. So the next item that I'll introduce you to, if you have picked the idea of how data which is normally distributed looks like, the next item is a normal distribution table. So a standard normal distribution table, is a table which has been prepared for every data which is normally distributed. So as long as you're told data is normally distributed, it will fit in here. The first column, this column, this is what you call the Z-score or the standard deviations. So these are the standard deviations. So the one I told you was this one here, one standard deviation. So this one, together with these, to get a second decimal place, these here. So for one standard deviation, not 1.1 is here. So that's a 0.34 that I gave you, rounded off. So these are the proportions. So the first item, these are the standard deviations. That's what this is, including the first row. Okay. So if I ask you a question, tell me what proportion of the items will be within one standard deviation. You just come here, you look for one, and this is the one. So it's 0.34, meaning that 0.34 of our items. So once we draw that, so 0.34 of the items will be one standard deviation below, and 0.34, 34%. So 34 plus 34, 68% will be within there. That's how we read that. So that's the first item. So we need to know how to read this table. Okay, but don't panic, because all of you will be experts on reading this table shortly. Okay. Now, what we do on this table, we just show you one side of the normal distribution. Why? Because these two sides are symmetrical, meaning they are equal. They're just a mirror image of the other. So what this table has shows us, it just shows us one side. So what is on this side is exactly what is on that side too. So those 1,000 readings that you have, all these will fit on this table. Some readings will be below the average, others will be above the average. This represents 50% of your readings of these. And this also represents 50% of the other 50% of the readings. So all these items, all these 1,000, the individual values will be covered by this particular distribution. Good. We have used the word average. So in every one of these distributions, there will be an average value. And some items will be below, others above the value. Now let's be more practical. Let us interpret this in terms of the question. So in terms of the question that we have, where is the average? Where is the standard deviation? Where are these values that you have here? And how do we carry out the value at risk? So now, let us see, apply this to the question that we have before us. So let's go to the question that we have. The question that we have, ladies and gentlemen, is a very straightforward question. We have a project. This project, the average return every year is 2.2. So the amount of money that we expect to make every year on this investment, what is expected is 2.2 million. But because of risk, we may get a return which is below or above 2.2 million. So we have invested, we have put your money in an investment in a project, which is 2.2. And according to you, you are very happy. 2.2 million every year is good money, isn't it? As a fund manager, as a bank. However, there is a risk that the return can be very low, but also very high. So then, if the variation is above this side, is that a problem for you? If you get more than 2.2, is that a problem for you? No, that's good news, isn't it? So the risk then is on this side. Your risk is on this side. So the value at risk then is on this side. The possibility is that actually in a given year, your return may be so low. And if you get very little money in a given year, then it means that you won't be able to carry out your other programs, isn't it? Yeah. Now, we want to know what is the value which is at risk at 99%, given a standard deviation of 800,000. So now let's interpret this 99%. Let's interpret it. The same interpretation, use it at 95%. Use it at 90%. At all these, you're going to do the same. So let us now break down the 99%. Let's start. The whole of this gives you 100%. So this shape here covers the 100%. This side covers 50%. And this covers 50%. That's the first item. So that's where these percentages come from. Now, we have said that we are not worried about this side. So from 99% we are saying, okay, so from 99%, we take out the 50. What remains is what? is a 49%. So this one is out. So 49%, and in here there's what? There's 50%. So now 49% from here. So if I count my 49% somewhere there. So that is my 49% there. And there's my 1% there. And that is what you're going to do also in doing your 95% and 90%. That's the breakdown you're going to do. So I want to find out what is the chance that my value can go into this portion. This portion here, the 1%. So this 1% is really your value which is at risk. So now, how much of my investment value can fall within there? Okay. So what we are going to do is we are going to go to the table to read how many standard deviations are represented by this portion here. How many standard deviations? Now you may say, Mr. P, what do you mean? I told you that one standard deviation represents how many items? 34%. Now, what of the 49%? How many standard deviations are represented by this 49% here? So we're going to go to the table together and check for the 49%. Want to find the number of standard deviations. How many standard deviations are represented by that? Now this time, if I tell you, tell me the standard deviation that are represented by 34% or 0.34. All of you do it, isn't it? Because I've shown you where it is. Huh? Now this time around, we all do not know. So let's look for it. We all do not know. So let's look for it together. So remember, if I'd asked you 34%, all of you would have come here and have said that the closest here would have told me that it's one standard deviations. Now this time, what of 49% or 0.49? So let's look for 0.49 together. 0.49. Can somebody tell us where is the figure closest to 0.49? What's the closest figure you can see? Huh? Is this the closest figure? Or is it that one? Or is it that one? Which one is closest to 0.49? Huh? Which one is closest?
0.4898.
4898 or 4901, which is the closest, Mr. Nkunguru, to 4900? Of these two, which one is closest? This one, isn't it?
Yes.
Now, how many standard deviations are these? You read is 2.1, 2.3.
3.
Let's read on top this side. Let's read. Out of here, what do you pick? So what is the standard deviation? It's 2.1. You pick 2.3 from there. And this one you're picking 0.03. So the standard deviation is 2.33 standard deviations. So this is the number of standard deviations that we are looking for. And one standard deviation, you already have a value for one standard deviation. So for now, I want you to pick the point called the point of 2.33. So it's 2.33. At 99%. Let us now use this information, do our interpretation, then you count 95%. By the time we reach 90%, all of you will be experts. So now let's do an interpretation. What does this mean? Let's go back to our question. So we go back to our question, all of us. Let's go. And very soon you'll be telling me that that is so mechanical. And it's true. Your process is so mechanical. So now, let's go. Let's draw a little diagram here. So a little diagram again, it comes. We have an investment which looks like this, and which looks like this. The average value every year is 2.2. And we are saying from there to there, you've got 2.33 standard deviations. That's what we have calculated at 99%. And each standard deviation is what? 800. So let's multiply. 2.33 multiplied by 800. How much do you get? Give me the answer. Give me the answer.
$1,864.
1,864,000. So let's subtract now. So from 2.2 you subtract 1,864,000. Can somebody give me the answer? From 2.2 you subtract
336,000.
336,000. So that is it, 336,000. Okay, now here is the interpretation now. Let's give an interpretation. The interpretation is that there's a 1% chance, 1% chance that actually this figure can go below 336,000. There's a 1% chance. This represents 1% chance. There's a 1% possibility that in every year, the return that you make can be below 336,000. On the flip side, there's 99% chance, 99% chance that in any given year, your return will be more than 336,000. Now, this is what the examiner is looking for from me. Do you think this knowledge can help you, or this interpretation can help you as a fund manager? Has anyone gotten a clue of how this can help you? Do you think it helps you see the risk that you are open to? So tell me something. Would you be worried if there's 1% chance that your return can be, let's use the word profit. Let's use a very simple term, profit. Imagine that the profit every year that you expect is 2,200,000. Now there's 1% chance that the profit in a given year can be below 336,000. Would that worry you? Tell me something. Would you be worried?
No.
Somebody says they wouldn't be worried.
I won't be worried.
Come again?
I won't be worried.
You won't be worried. Mhm. So I know it will take you some time, but this is a starting point of you understanding the concept. And once you find it, once you understand, you realize that every time we normally use 99% or 95%. Those of you who work for the banks, you test the risk at 95% confidence levels. The Basel report recommends 95%. What I'll be looking at really is, what do I need to do with the money? What do I need to do with the money? In the worst case scenario, will I have enough money? Because I'm looking at 2.2 million. Now it can drop and drop and drop, and there's 1% chance that it can even be lower than that. So I need to ask myself, what do I need the money for? Yeah. But certainly 1% below 336 is quite very small. Good. I want us now to repeat this whole process at 95%. Can you do that? Let's repeat this at 95%. Now I know this time around to be much easier for you. So you say, okay, fine. That's the normal distribution. That's your 2.2 million. And this side, we don't even need to say much. That portion then becomes what? What does that portion become? So then, from there to there, that is what? Or 0.45. So we're going to look for the number of standard deviations so that we can multiply by 800. So we want to look at what are the standard deviations. So that's what we want to look for. At 95%. And so we have already taken out the 50% is out. So we're looking for 0.45. So if you didn't follow the first one, let's work together on this one. Let's work together on this one. 0.45. 0.45. Are you seeing a 0.45 or 45000? The closest? What is the closest?
The closest I can see is 0.4505.
Yeah, that one is a tricky one. Eh? Under which one now? You must pick a standard deviation here. Guide us. What standard deviation is that? From this side.
But I think we have to get the average here.
Okay.
Yeah, we have
So
to get the average.
there's 44.95 and 45.05. So from this side, what is it?
1.6.
1.6. So they deviate 1.6. For the second decimal place now, let's check now on top here. So it's in between these two. So you can pick any, or you can say, can we do an average of these two? So if we do an average, then we have 3 decimal places. So it means that it's 1.1. So 0.04 plus 0.05. That is 0.09. Divide by 2. That gives us what? 0.0. We get something like this. So we've got 1.645. So this is the number of standard deviations. So let's go. You multiply now 1.645 multiplied by 800,000. How much is that?
So we're getting 1.316, 000.
1316.
000.
Okay, so again you go. Let's draw a diagram again. Let's draw a nice diagram again. Okay. So I'll put our nice diagram here. So we are saying we have something like this, and we have something like that. Then we've got that is a 2, 2. And now you've got a value. So this was the 1.645. And this one you have calculated is the 1316. So again, you subtract for me 2, 2 less 1316. What do you come up with?
We're getting 884,000.
884,000. So this is 884. Can somebody give us an interpretation? Can somebody give us an interpretation?
Okay, I think there's a 5% chance that the annual return would be less than 884,000.
Excellent, well done. Do you think this is beyond you guys?
Oh, this is straightforward.
And normally, you don't even have to look for this 1.645 because it will either be at 99% or at 95%. We have seen the other one is 2.33. The other one is 1.645.
Mr. Piri,
Yes, please.
I was trying to do some reasoning with the first one. Because the first one, which was at 2.33, it was lying in between. The other one was 2 greater, the other one was 1 lesser. Now, I tried to do a comparison with 0.45. There was a difference of 5.5. So maybe that could have been the reason of finding the average.
Yeah, yes. That's
because
right.
it was like in between.
It was in between, yes. It was in between. We couldn't round it off. But if somebody say, me, I was going to go for 1.64, it's okay. Somebody say me, I was just
1.5.
1.65. It's okay.
Okay.
Hmm.
And
So
then standard deviation is also multiplied with standard deviation.
yeah, because this is the value of one standard deviation. So if you've got 1.645 of standard deviations, you multiply by that to compare to the money
That
value.
is standard.
Okay. Good. So we have enough time between now and the exam for all of you to really master 95 and 99%, but even 90%. Now your question went a step further. Let's illustrate the last item.
And then just on that one,
Yes, please.
the explanation for, so the higher figure, the higher percent should always be, the return can be above. That is the explanation. And the
Yes.
lower figure, the return will be.
Which lower figure? Maybe it's better to use the figures. Use
Okay, let's say the explanation, I take 99%. The explanation is that there's a probability that the profit will be above 336. And then the same explanation applied.
There's 99% chance that your profit
Yes.
will be above 336.
So the same explanation also applied to 95, meaning that
There's 95% chance that your profit will be above 884.
so the bigger the figure, the bigger the return in short. Explanation.
Okay. What I would encourage you to do is use a small little diagram. That's what I would do. But you must be talking about that value there. So it could be 1%, or it could be 5%. And then you mark this value there. So you must be saying 1% or 5%. So it's better to use a diagram where you say, just I need to know my average. So you know this average all the time. Then you knock off your standard deviation. Like in that case, you have 336. With 1% chance of being that side. The other one was 884. There's 5% of being that side. So you can focus on this percentage. If you don't want to talk about 99, 95%, focus on these 1% and 5%.
Okay.
Now the question says for 1 year. So what we have done is we have looked at the value for risk for 1 year. Now what of over the project's life of 5 years? So 5 years, how much are you expecting? It's 2 multiplied by 5. How much is that? How much is that?
$11 million.
11 million. So overall, this project is expecting 11 million. Now, what's the value at risk? So again, you do the same. Okay, 11 million. So the average is 11 million. Then you multiply. The first one was 2.33 multiplied by 800 multiplied by, now notice this, the square root of the 5 years. That is the only thing that you need to do. 2.33 multiplied by 800, not multiplied by 5, no, but multiplied by the square root of 5 years. Don't multiply by 5, but the square root of 5 years. The next one will be 1.645 multiplied by 800 multiplied by the square root of 5 years. So the first one, please, can you give us what's the value for the first one at the, this was our 99%. So at 99%, and this was at 95%. Give me the answers.
4168 031
4168
031.
031. So you subtract. What do you have? You subtract
6831969.
6831969. So again, you do your small diagram. Remember, you do a small diagram, you say, okay, so over the 5 years, this project is expecting how much? 11 million. However, it may not be, there's a 1% chance that actually over 5 years, they may end up with what? 6, 8, 3, 1, 9, 6, 9. So there's 1% chance that actually they can get something below that. There's 1% chance. %1 chance. Again, at 95%, can somebody multiply? What do you get? What do you get?
And then it'll say 95%.
What do you get?
Start with the expected return, which is 11,000.
When you multiply this, what do you get?
We get of
1.645 multiplied by 800 multiplied by the square root of 5. What do you get?
the
The 5 is 5 years. The 5 comes from the 5 years. That's where it's coming from. Okay. What's the answer?
2942.
Come again?
2942. 665.458.
So 665.
Mm.
You subtract, what do you get?
8057335.
8057
335.
5. So you got your interpretation again. You got your interpretation again. That you are expecting 11 million. But there's a 5% chance. There's a 5% chance that actually this can go below what? 8057 335. There's a 5% chance. So this is what we call value at risk. And you have demonstrated at 99% how to get a value at risk. And at 95%. And you have demonstrated value at risk for 1 year and the value at risk for 5 years. Okay, so what we expect is that before the next class, please go through. If you have any challenge, let us see how it goes. And on top of that, I've given you an assignment, which I want you to do. Next class, I'll find another assignment, a 25-mark question, which I want you to run with, involving value at risk and also other aspects. Okay. So I'll give you a lot of homework so that you can sit on your own and do a lot of work with your computer so that you start manipulating these within the computer. All right, people, that was our work for today, focusing on value at risk. The other elements, when I'm doing them with FM people, I'll ask all of you to come on board so that you can observe how we do the basic risk assessment in NPV computations. All right, good night to all of you. We'll see you Thursday sometime.
Thank you.
Thank you.
Thank you. Thank you.